Hi guys, welcome to Concept of Mathematics, and today we will see how to find total number of factors of a given number. Also we will see how to calculate sum of all factors of a given number. So how can we find the total number of factors of 1,498,176? More interestingly, if I would say without writing all factors, we can tell the total number of factors, and most surprising part, we can calculate the sum of all possible factors of the given number without writing all factors. So let us start. Suppose we want to find the factors of 12. Then we have to look for the set of numbers which can completely divide 12. Okay? And that can be written as 1, 2, 3, 4, 6 and 12, because all of these numbers can divide completely 12. But this method, listing of divisors, becomes worst when we are dealing with some large numbers. As for example, suppose we want to find factors of 100, we have to list out all the divisors of 100. So these are as follows: 1, 2, 4, 5, 10, 20, 25, 50 and 100. So the total number of factors of 12 equals 6, and the total number of factors of 100 equals 9. If someone asks to find factors of 1,498,176, then listing the divisors method becomes very tedious. So we have to look for an effective and easy method to deal with such type of numbers. By using long division method, 12 can be written as 2 squared times 3, and 100 can be written as 2 squared times 5 squared. If I would say that all possible factors of 12 can be found by multiplying this quantity and this quantity, is this correct? Okay, let us check. This whole expression can be written as 2 to the 0th times 3 to the 0th plus 3 to the 1st plus these quantities. Okay, now 2 to the 0th power equals 1. So we will evaluate this. We will get 1 plus 3 plus 2 times 1 plus 3 plus 4 times 1 plus 3. Okay, this would be 1 plus 3 plus 2 plus 6 plus 4 plus 12. So this will list out all the possible factors of 12. 1 is factor of 12, 2 is factor of 12, 3, 4, 6 and 12. Here we have got the same result. Similarly, list of all possible factors of 100 can be obtained by using this product, and this can be written as 2 to the 0th times 1 plus 5 plus 25 and so on, and this will gives us all possible factors of 100, that is 1, 2, 4, 5, 10, 20, 25, 50 and 100. The total number of factors 9. Here we have got the same thing. Now we will make some observation. 12 can be written as, in terms of prime factors, 2 squared times 3. 100 can be written as 2 squared times 5 squared. And we have already seen that the total number of factors of 12 equals 6, and the total number of factors of 100 equals 9. So, what is the relation between this quantity and the exponents of the primes involved in the factorization? If I find products of successors of the exponents of the prime, what will we get? Suppose for 12, the successors of exponents of 2 and 3 are 2 plus 1 and 1 plus 1. Okay, because here exponent is 2 and 1. Okay, so the successor of 2 is 2 plus 1 and the successor of 1 equals 1 plus 1. If we would calculate the product of this quantity, what will we find? This will be 3 times 2, and in turns it will be 6. We observe that the product of successor of exponents equals the total number of factors of a given number. Okay, let us make it clear by taking 100. If this is correct, so it should work here also. Okay, successor of exponent of 2 is 3 and successor of exponent of 5 equals 3. Okay, if I would calculate the product of this quantity, I can say that it is equals 9. So this is same as the total number of factors we have calculated earlier. Now we will generalize the observations we have made earlier. Suppose a given number n can be written as a to the pth power times b to the qth power times c to the rth power, where a, b and c are all primes and p, q and r are natural numbers. The total number of factors of n can be written as p plus 1 times q plus 1 times r plus 1. Okay, this will give the total number of factors of this number. Now we will see our target question, that is how to find total number of factors of 1,498,176. This number can be written in the form of prime factorization as 2 to the 6th power times 3 to the 4th power times 17 to the 2nd power. So as per our formula, the total number of factors equals product of successors of exponents. So successor of 6 equals 7 times successor of 4 equals 5 and successor of 2 equals 3. Now by multiplying these numbers we can get 105. So the total number of factors of this number equals 105. Now let us see second part of problem, that is how to find sum of all factors of the given number. Let us take a smaller number. We have already seen that the prime factorization of 12 can be written as 2 squared times 3. Also we have seen that sum of all factors of 12 can be written as product of 2 to the 0th plus 2 to the 1st plus 2 to the 2nd and 3 to the 0th plus 3 to the 1st. Okay, so if we calculate these numbers, we will get this would be 1, this would be 2, and this would be 4, and this would be 1 plus 3. By multiplying these numbers, we can get 28. So the sum of all factors of 12 equals 28. Also, since 100 can be written as 2 to the 2nd power times 5 squared, so sum of all factors of 100 can be found by using product of these numbers. Okay, power of 0 is ranging from 0 to the highest exponent, that is 2, and similarly for 5. So 2 to the 0th is 1, and 2 to the 1st is 2, 2 to the 2nd is 4, and similarly this can be written as 1 plus 5 plus 25. Okay, sum of these numbers is 7 and sum of these numbers is 31. So finding product, we get 217. So the sum of all factors of 100 equals 217. But summing the individual factors becomes very tedious when we are dealing with a large number. Now our target question, that is how to find sum of all factors of 1,498,176. Let us write it in the form of prime factorization, which in turn equals 2 to the 6th times 3 to the 4th times 17 to the 2nd power. And as earlier we have done, sum of all factors of number can be written by using which equals 2 to the 7th minus 1 by 1 times 3 to the 5th minus 1 by 2 times 17 to the 3rd minus 1 by 16. Product of this expression, let us call it as A, B and C. Okay, so as we know, sum of n terms of a GP equals A times R to the n minus 1 by R minus 1. Okay, so for this sequence, A is 2 to the 0th and R is 2, and the total number of terms equals 7 minus 1 by 2 minus 1. Okay, and for expression B, this would be 3 to the 0th times 3 raised to the power 5th minus 1 by 3 minus 1. And for expression C, using this formula, the first term is 17 to the 0th and common ratio is 17. Total number of terms is 3 minus 1 by 17 minus 1. Okay, 2 to the 7th equals 128 and less 1 equals 127. 3 to the 5th equals 243 minus 1 by 2 times 17 cubed equals 4913. Okay, minus 1 by 16. So 127, and this would become 121, and after calculating this fraction we will get 307. Now our task will be finding product of these numbers, and this will be very huge number, that is 4,717,000. and 669. Wow. So finally we get sum of all factors of this big number. Okay, this was our target. Now we will generalize the result we have found earlier. Suppose a number can be rewritten in the form of prime factorization as a1 to the p1 power a2 to the p2 power times an to the pn power. Okay, so by using the previous results we can find sum of all factors of n equals a1 to the p1 plus 1 minus 1 by a1 minus 1 times a2 to the p2 plus 1 minus 1 by a2 minus 1 and so on up to an to the pn plus 1 minus 1 by an minus 1. Also we can calculate total number of factors of n equals product of all successors of primes. Okay, so it will be p1 plus 1 times p2 plus 1 times p3 plus 1 and so on up to pn plus 1. We have done our generalization of the formula. So that's it. I hope you have enjoyed watching this video, and if you like this, please comment, share and keep motivating us to record the video. Okay, till then, goodbye.